Prvo predavanje će održati kolega Andy Pearson na temu otpornosti rashladnih sistema, a ja ću sad ukratko reći par reči o kolegi Andy Pearsonu. Andy Pearson is the Group Managing Director of Star Refrigeration, UK's largest independent industrial refrigeration and heating contractor. He's one of the leading figures in refrigeration industry, fellow ASHRE and member of various societies related to refrigeration. He's the lead author for UNEP's Refrigeration, Air Conditioning and Heat Pumps Technical Options Committee. Also, for many years, more than 15 years, he's a valued member and participant of our Congress in various roles as author, as keynote presenter, as a plenary presenter. Dear Andy, the floor is yours. You can start your presentation.
Thank you very much, Marco. And before I start, I would like to pay tribute to the translators who are doing an absolutely brilliant job. Without them, I would be completely lost at this presentation. I only say to the translators, I hope that I remember to speak slowly enough to give you half a chance to translate. I have a tendency to get excited about the topic and to run away and go very fast. So I will try to keep it slow. So the topic, challenges and opportunities in refrigeration system resilience. I would like to say, first of all, that it is a real pleasure and an honor to be invited back to the beautiful city of Belgrade, as you can see in the photograph. I told everybody I was coming to Belgrade and it would be cold and foggy and damp, and it's absolutely beautiful. So thank you for laying on such beautiful weather just for me to keep me happy. It's a delight to be here. Of course, I use this photograph for a second purpose because some time ago, a gentleman who lived a little bit south of here made the statement, it is not possible to step in the same river twice. And what he meant was it might look the same, but the water has moved on, that things have changed, and it's not, in fact, the same river. That gentleman was the ancient Greek philosopher Plato. And when I say a while ago, it was 2,500 years ago. But the one thing we can say that has been constant since Plato first said that you cannot step in the same river twice is that things keep changing. So the change is the only constant. Much more recently, about 120 years ago, an American philosopher said, if life gives you lemons, make lemonade. And this was picked up by the author Dale Carnegie and became a very popular saying. And really, what I'm talking about this morning is making lemonade. I became a design engineer in the company Star Refrigeration almost 40 years ago, 1986, when I graduated from university. And I worked in the design department and then worked my way around various parts of the company. And 1986 was also the year that the Montreal Protocol was published. So my entire career has been driven by a variety of influences on the choice of refrigerant. Some of them from 1986, ozone depleting potential, some of them coming in more recently in the 1990s, like global warming potential. Price, not only of the refrigerant, but of the refrigerating system, has always been a big factor. People talk a lot about flammability and toxicity, and there's a lot of misunderstanding about both of these topics. But the key mission for all refrigeration engineers is to design safe systems. So the flammability of the refrigerant, the toxicity of the refrigerant are just factors for the designer to take into consideration in producing the plant. PFAS has become a really big topic just in the last 5 years or so. I'm not going to say a lot about that because Alex Pashai will talk about this in the panel session tomorrow morning. So I really encourage you to come and hear what Alex has to say about that. But it's a huge topic and will have a massive influence on the choice of refrigerants in the few years ahead of us. And then the security of supply of refrigerant is a big issue as well. Not just for the fluorinated refrigerants, but will it be possible on a very hot day when suddenly a lot of CO2 systems have lost some charge to get hold of refrigerant CO2 in a hurry, not only the refrigerant, but the technician to charge the system as well. So these challenges have been a constant part. As Plato might have said, you cannot step in the same challenge twice. But for my entire career, these have been the issues that I've been grappling with. However, we have a saying in English that we moved the goalposts. In other words, that this used to be the target, but now the target is over here. That's kind of what's happening. But I would say not only have we continually been moving the goalposts in terms of refrigerant choice, but actually the ball has burst in the meantime as well, that we have some very, very difficult choices to make now. The politicians seem to think that they can continue to give us new targets, new challenges, move the goalposts again. But the reality is that the questions are getting more and more difficult, and the time to respond to those questions is getting shorter and shorter. So when I talk about challenges and opportunities, these are the issues very much that I have in mind for refrigeration people. But it's more than just refrigerant choice. There are 4 other factors that I want to draw to your attention, and I'll explain the factor, and then I will explain the current situation for each of these factors, and then I will explain what I think is perhaps coming in future in each of these cases. And as I said at the start, it's all about making lemonade from these lemons that are presented in front of us. So let's start with energy. Well, the energy market is changing massively at the moment, and this will have big implications for refrigeration systems, as I will describe later. We're seeing a lot more renewables, not just in wind power, solar power, hydropower. Serbia is very well placed for wind power and for hydropower, so you have quite a strong renewables infrastructure already. But one of the things that has brought to the entire European landscape is a far greater interconnectivity between countries, between regions, even between the isolated United Kingdom. We now have subsea interconnectors with France, with Belgium, with Norway, with Denmark, and energy is continually being transmitted one way or the other through these cables under the sea. So this interconnectivity really changes the map in terms of electricity availability and supply. Hydropower is becoming increasingly important. I checked when I was preparing this presentation in terms of pumped hydro storage, which has always been a thing in Scotland. Since I was a small boy, we've had pumped hydro storage systems. Very, very small in the global scheme of things. The 13th largest pumped hydro system is in Wales, and the 15th largest is in Scotland. But the vast majority of these systems are in China. And what is really interesting is that there are 180 pumped hydro schemes already in existence in the world. There are another 300 in planning or under construction at the moment. And of the 300, 295 of them are in China. So they are completely transforming the electricity market. And it's difficult to see how something so far away could have an influence on the Serbian market or on the UK market. But that pumped hydro storage is really going to transform the way in which we buy and sell electricity. And I'll come back to that later. And then there's also things like, in this example, a Carnot battery, a method of taking very cheap electricity and storing that power for a long time, not just in a battery, but actually storing either compressed gas or high temperature and then regenerating power. So the sun shines during the day, but you need electricity at night. What are you going to do? Well, a Carnot battery, which is rotating machinery, thermodynamics, and heat exchangers. So it's very much what I do for a living, is one possibility in terms of storing that power. Health and safety law has changed enormously, even just during my career. And we now have a whole host of factors that we need to bear in mind. And in choosing not just the refrigerant, but the refrigerating system that you put it into, health and safety considerations have grown possibly faster than any other legal constraint. All kinds of things, not just to do with the refrigerant itself, but working practices, working hours, level of competence required, level of training required. And the fact is, accidents happen and accidents still happen, and it's about minimizing the risk and ensuring that workers are kept safe. But things that were permitted when I started in refrigeration are now no longer permitted. So if you're thinking about designing and building a new system, you cannot step in that health and safety river twice. It has moved on, things have changed, and you have to take that on board. Other regulations, well, these come in all kinds of different flavors. We have local regulations, for example, constraints on noise, issues related to Legionnaire's disease, and building control requirements on what you can and you cannot do, particularly related to ammonia. In different countries around Europe, there are very, very different regulations. So we might look at Europe as one entity, but what you're permitted to do in Germany is not the same as what you're permitted to do in France, and other countries have their own local regulations as well. So it's very important to pay attention to that. If you're looking for a universal system, you need to take on board the fact that it's not going into a universal regulatory environment. We have national regulations. These are a lot to do with things like ensuring fair competition, anti-corruption, anti-discrimination, anti-slavery, all constraints on business that didn't exist previously, and all of which have an impact on the way that we go about defining and constructing our systems. And then international regulations. I only want to mention two things here. The possibility of sanctions against a country, and we saw really, really severe issues 3 or 4 years ago with the supply, for example, of aluminium and of electronic components, that we were quoted lead times on PLCs, programmable logic controllers, of 102 weeks for the supply. And I thought 102 is a very precise number. 2 years was the reality. So when you have to wait 2 years for the electronic to control the plant, it disrupts the entire operating universe. And then more recently, tariffs, particularly from America, and then tit-for-tat tariffs with other countries. The problem with this is unpredictability. You know, when the rules are changing on a weekly basis, it's very, very difficult to plan for longer-term activity. And then new technology. I deliberately picked an old picture because I didn't want to favor anybody's particular new technology, but there are big changes being made in the refrigeration world. Firstly, in styles of condenser with things like microchannel coming in, and in compressors, completely new compressor technologies. A very, very exciting time to be a compressor designer in refrigeration, and in evaporators as well. But more so, and I'll talk more about this in a moment, the export of data from the system is something that is growing at a phenomenal rate, taking information off-site and applying computing power that is beyond anything that was ever available to us before. I liken this to, we used to go looking for problems in plants with a flashlight, and now we have a massive million-candle searchlight to find these issues. We can highlight things that were never highlighted before, and it has a massive influence on the performance and the efficiency of the system. So what does all this mean in terms of refrigerating system choices at the moment? Well, as I said earlier, when life gives you lemons, make lemonades, you have to take each of these factors and consider, when I'm thinking about replacing my existing plant or building new plant, how am I going to turn these things to my advantage? What am I going to do that makes my refrigeration system the most attractive that it can be? One of the things that has already come in the domestic market, certainly in the UK, is half-hour pricing of electricity. Now, I don't know that any of our customers for the industrial refrigeration market are using half-hour pricing at the moment, but it is coming, and this is a direct result of the increased use of renewable energy, particularly wind and solar, both of which are intermittent. Solar is quite predictably intermittent. Although the day might be cloudy or sunny, it definitely will not be delivering any electricity in the evening and overnight. So it's predictable. Wind is much less predictable. It varies even from what the weather forecasters say, although weather forecasting is becoming much, much more of a precise science. But in Europe, we can have what the Germans describe as Dunkelflaut, which is dark, still days, where there's no solar power and there's no wind power, and the Dunkelflaute can last for up to 2 weeks. So when you're reliant on renewable power to balance the grid and you have nothing for 2 weeks, you have a massive challenge. I don't expect you to be able to read the numbers on this table, which is from a domestic user from a couple of years ago. All you need to know is that the blue boxes are every half-hour period when the price of electricity was negative, when the electricity company were paying the user to use electricity. And when you think about all that we've ever learned about refrigeration efficiency, this turns it completely on its head. What does this mean for the operator of a refrigeration plant when they will pay you to take electricity from the grid because they need to balance the load? So, I'll come back to that in a moment. And then we see fashions in refrigeration to an extent. This is a high bay warehouse in England, and the first high bay warehouse I was involved in was constructed in 1995. But in the last 5 years, we've seen a massive upsurge in this smaller footprint, higher building, 30 meters high, 100 feet high for the American colleagues. Very, very much more energy efficient than a traditional system. We have installed high bay systems in the UK where the specific energy consumption is about 4 kilowatt hours per cubic meter. This is about 10% of the European average for efficiency. So we're only using 10% of the energy that's used in an average cold store in Europe. Lots of reasons for that. When I spoke at KGH last year, I touched on some of those reasons. So the information is available to you in the archive. But this is, to my mind, a fashion trend. And I don't know what the next fashion trend will be in cold storage. At the moment, it's high bay. Once upon a time, high-rise tower blocks were the fashion in domestic housing, and now we're demolishing them all and building communities. So maybe high-rise is here to stay, maybe it will change. And the electricity bill, I already mentioned the energy efficiency aspect, but the combination of half-hour pricing and focus on efficiency makes the life of the system operator very, very confusing. How do you motivate your staff to keep the refrigeration system operating efficiently when the electricity company are paying you to take electricity from them? And if you're only interested in efficiency because you wanted to keep your bill small, you're missing the point, because there are lots of reasons why running a refrigeration system efficiently is important. And it used to be quite comfortable for us. We could rely on electricity pricing to motivate the end user to pay attention to efficiency. But more recently, we've lost that motivation, and it's much, much more difficult now to sell energy efficiency as a topic because power sometimes is very cheap. What we need to learn to do is control our systems differently to take advantage of the cheap electricity, but also to educate our technicians so that they understand that low electricity bill is not the only reason for being interested in energy efficiency. And I would argue that really the whole topic is about risk reduction. And the finance people in companies are happy to discuss risk reduction because they get it. They understand that reducing risk is the prime objective of the company, operate in a low-risk environment. Engineers somehow don't seem to get that. You know, risk is what makes my job worth doing. It's what makes me get out of bed in the morning and go and solve other people's problems. So getting that message across to engineers that we need to reduce the risk of continuity of electrical supply. What happens if there is Dunkelflaute and suddenly energy becomes very expensive for a long time? What happens if the plant is operating inefficiently in the springtime, maybe February, March? That's okay. And then suddenly a hot spell comes in April or May and you discover that actually you don't have enough refrigerating capacity. So we'll touch a little bit more on these things in a moment, but a particular example that I'm seeing more and more frequently now is the use of transcritical CO2 systems in areas that formerly would have been industrial ammonia plant. And the people that are promoting this are saying it's very safe, it's very efficient, it's very reliable. But what they misunderstand is the effect of high ambient on a CO2 system. So I wanted to give an example here. I'm comparing CO2 R744 with R134A, and the premise here is that the green cycle diagram shows you what happens when the ambient is 32 degrees, and the red cycle diagram shows you what happens if the ambient rises to 42 degrees. 32 used to be a fairly common ambient design condition for industrial systems. 42, we're not there yet, but we're on a path that's taking us in that direction. Everybody knows that in warm ambients, CO2 is less efficient. They don't seem to understand why CO2 is less efficient. And the important thing is, it's not the same as traditional refrigerants. You cannot step in that river twice. It's a different thing. So, if you look at the change of refrigerating capacity and the change of compressor input power, the two of these combined give you a COP change. And you can see that CO2 is not good when the ambient rises by 10 degrees. The COP reduces by 40%. This is massive. But traditionally, people would have said, that's okay, because it's only for a couple of hours in the afternoon. If my electricity bill goes high for a couple of hours in the afternoon, I can live with the consequences of that. But look more closely at the capacity change column. The big difference with CO2 is a reduction in capacity, whereas with R134A, the big difference was an increase in power. So in diagrammatic form, you can see with R744, the green block shows you the reduction from 32 degrees C ambient to 42. The red is the cooling capacity when you're at 42. And very visibly, from a graphical perspective, with R134A, the reduction is much, much less. So the reason the plant is inefficient is not increased compressor power, it's lack of cooling capacity. And if you run out of cooling capacity in a cold storage warehouse, you're in deep, deep trouble. You cannot afford to do that because your entire business continuity is at risk. The stock could be spoiled. The customers could be dissatisfied. You could be in breach of contract. You could be sued. All of these factors will follow. It's not just about the electricity cost being high. And just as a passing aside, because really I'm an ammonia guy, you can see ammonia also has a reduced COP compared with 32 to 42 degrees. But the reduction is less than half the reduction that you would see in a transcritical CO2 system. So ammonia is very forgiving. It responds very well to high ambient temperatures. When I joined Star Refrigeration, I was taught that on big systems we should use evaporative condensers. And what we've learned over the years is actually, on a seasonal efficiency point of view, air-cooled condensers are much, much more attractive with ammonia than they are with HFCs. So even on quite big systems, we would use air-cooled systems nowadays. So moving on, future developments. Well, there's a big issue at the moment within the safety standards in the refrigeration world, not just in Europe with SEN, but also in the ISO standards. Should we relax the strict requirements on the use of hydrocarbons as refrigerant or not? And there's a very strong argument that says we should not write standards that deliver anything that is less safe than what we have at present. But at the same time, we have butane canisters used in room air heaters in houses, in central heating systems, and even the white tank is a propane tank. You can see right next to a domestic house, 500 kilograms of propane in the tank. Why are we worried about, is it 500 grams or 1,000 grams in the air conditioner inside the house when we have 500 kilograms in a tank in the garden? It just does not make sense. So I believe that in the fullness of time, we will see a change in the standards. I'm actively involved in the redrafting of those standards, and it is an incredibly difficult job. There is a huge opposition to this change, and it is not going to be an easy road forward, and it will lead us to some fairly illogical conclusions in the short term. So I'm not optimistic about this, but in the fullness of time, I believe it will come. Propane, of course, was advertised in the 1920s as the safety refrigerant. So in the 1920s, they were comparing it with sulfur dioxide was used as a refrigerant, and it was a bit toxic and very smelly. so nobody really liked it. Methyl chloride was used as a refrigerant, and it was a bit smelly and very toxic, so not the same as sulfur dioxide. But which would you rather have? Something that is so horrible that you keep away from it, or something that you don't notice the smell until you're dead already? You know, it's a tough choice to make. But propane was proposed as the odorless safety refrigerant because it was non-toxic and it didn't carry the disadvantages of the others in the market at that time. And it's still being sold. You can see this canister of R290 propane from the Indian market is still being marketed as a safety refrigerant in some parts of the world. There are issues with it, and we should not discount the issues or trivialize the issues, but we should be delivering safe systems that recognize the properties of the fluid that is used. And I would not characterize propane as being less safe or more safe than any other refrigerant. It's about what you do with it that's important. But it's perfectly possible to engineer and to operate propane-based refrigeration systems safely. There is no doubt about that. Would you be happy having propane in something like this, a cassette of a split air conditioner? That's a big open question. That's really the core of the debate at the moment in the safety standards, is to what extent should we be comfortable with this? But I think there's a lot of misinformation flying around, so it's very difficult to see where we're headed. And as I said, the standards are under review at the moment, both in ISO and in SEN. Very interesting, the differences. The ISO standard was rejected on the first pass and is being modified. The SEN standard was accepted on the first pass, but it's at an earlier stage. So again, difficult to see where we'll end up. And then looking at energy, the use of pumped hydro, I mentioned earlier, is a big thing. I think this is a beautiful photograph from Serbia showing a pumped hydro system. The scope for a lot more. I used to think we can't have enough pumped hydro because it will completely ruin the entire landscape. But projects that are being proposed in Scotland at the moment are actually very, very contained. They're in very small areas, but they provide a significant benefit to the grid, particularly in terms of dark start, which, having got rid of all the coal-fired and now getting rid of all the gas-fired power stations, is a big problem for us. And again, what does that do to the guy who's reading the electricity bill in future? His life is getting more and more confusing all the time. And then computer developments. This is a picture of IBM's 53-qubit quantum computer. It looks marvelous, doesn't it? It's out of science fiction, but it is it's a really interesting development for everybody, because the way that the computing power increases with quantum computing is not the same as with traditional computing. Everybody, I guess, is familiar with Moore's law. Gordon Moore in 1965 saying the number of transistors on a chip will double every 2 years. And that has remained true from then, from the 1960s until now. But there's obviously a limit. And if you fast forward Moore's law by about 200 years, there would be more transistors than there are atoms in the entire universe. So obviously it's going to give out at some point. If you look at the number of qubits in quantum processors, there's been doubling roughly every 5 years. So there's a similar law to Moore's law, but starting in 1989, a doubling of the number of qubits. By the time we get to 2040, this, what I call exponential increase in quantum computing capability, will match the traditional computing capability with the total number of atoms in the universe. That's by 2040. It's just 25 years away, a phenomenal increase in power. And if you think about this IBM picture, the computer on the black and white photograph here is what computers looked like in the 1950s, when every single bit was visible. This is a 64-bit computer, and every single bit is a valve. Quantum computers at the moment are in the same state. We can see every single bit in the quantum computer as computers in the 1950s were. And if you think about the computing power in something like this now, this is where computing is headed, but it won't take 70 years to get there. We will be there in the next 10 years. This is a massive change for the entire world, but particularly for the refrigeration world. And what will you do to make your operation less risky if you have that much computing power is really the question, because it's coming fast. You know, it will be here soon. One of the things it will do is it will enable us to put sufficient computing power out on site that we can run a digital twin of the existing refrigeration system alongside the actual refrigeration system. And the way that we control the plant will be based on that interactive exchange of data between the digital twin and the real world. And it will enable us to run more efficiently, more reliably, more predictably, and it basically will reduce risk. So again, back to risk reduction. Another future development is that balance that I mentioned earlier between low energy price and low energy use. How do you keep people motivated to be efficient when the energy is effectively free? One of the things that the increase in computing power is going to bring is that kind of a benefit to the operation of the system. But it's going to be difficult. This is probably, in my mind, the biggest challenge that operators of refrigeration systems face, is keeping the focus on operability when running costs has been transformed. I don't see an easy answer to this, and I see significant negative consequences if we don't get it right. So some conclusions. As I said right at the start, change is inevitable. It's always been with us. It always will be. You need to embrace it. You need to move towards the change and figure out how to turn it to your advantage rather than running away from it. Look at tariff options as a way of minimizing operating costs. This is a sensible thing to do. I'm not speaking out against that. I'm absolutely in favor of it, but don't let it get in the way of keeping your system operable in other terms, keeping it effective and reliable. You need to look at new systems very, very carefully and choose wisely to ensure that they are compatible with what's coming down the track in the next 2 years, 5 years, 10 years time horizon. One of the differences I observe between industrial refrigeration, where I work, and commercial refrigeration is that the supermarket might do a refresh every 5 to 7 years, and the plant is considered to be out of date by then. Whereas we're maintaining and servicing plant that is 30, 40, 50 years old. So if you want the plant you install this year to be in operation in 30 years' time, you need to pay attention to these long-range trends and figure out kind of where things are going. Safety is really, really important in all of this, because in terms of risk to a business, it's not the risk that somebody has an accident, it's the risk of the consequences of that on your business. So it's really, really important that we take safety legislation and embrace it and turn it to our advantage. That's very much about making lemonade from the lemons. Everybody rebels against the regulations and says, oh, it's dreadful that the government forced us to do these things. I don't see it that way. Don't gamble. It's absolutely all about risk management. I've used that word several times in the talk, and I would just repeat it one more time. You have to minimize the risk for the business, and that's the financial risk, the operable risk, the risk of breach of contract, all of these things. And finally, don't expect the answer to come from legislation. Legislation always, always, always lags behind. The smart people have seen the change coming, and they've already reacted to it before the legislation comes in. If you're waiting for the legislation to force you to do something, I think you're on the losing track. So be willing to forecast what's coming and then embrace the change and turn it to your advantage. That's all I have to say. Thank you very much for listening. It's been a pleasure.
Thank you, Andy, for your inspiring presentation. It was great, as always. Now we are heading towards our second plenary presentation on the Kosmos of the built environment and challenges and opportunities. Constantinos Balaras is a mechanical engineer, ASHE fellow, and research director at one of the institutes of National Observatory of Athens. He leads the energy conservation group focusing on building energy efficiency, HVAC systems, indoor environment quality, sustainable urban development. Widely published and well-recognized author and researcher with more than 10,000 citations. Last but not least, Kostas is honorary member of SMEITS, and also for many years on in various role part of this Congress. Kostas, please, the floor is yours.
Good morning, and of course I'm very thankful to be part of this great society and of this Congress. I've been in Belgrade quite a few times and always excited to be with you. And actually today, as we start this event, we have an opportunity to share experiences and enter into the cosmos of the buildings. And we care, and that's the interesting part of my talk, my presentation today, is that it touches us because that's where we spend most of our time. We live in buildings, we work in buildings, hopefully we have fun, and we are looking for the solutions. We're looking of ways to ensure that they're good for us, their health, environment, it is a safe environment, it is a resilient environment that will withstand changes and impacts from the outdoor. And, well, it becomes interesting, connects with the previous presentation. They use as a heat sink a lot of energy. And, well, that, I don't really care, the last part now. They cost. So it is costing us to operate, to live in, and that's where it starts getting interesting, I think, to all of us. So talking about energy, you heard about a specific use about refrigeration. Now, in buildings, we have all kinds of end uses. We have all kinds of equipment, both in our homes and the non-residential. Now, depending on where you are in Europe, and you see here the different countries, it is more or less important. It is more or less important because you have different design, constructions, operating conditions, and you see diversity. If anything, out of this picture, you see, God, they're all over the place. So that means we can learn also from each other. Because we want to move towards low energy use, yeah, that's no brainer. The less energy you use, well, it's gonna cost me less. So that's one part of the puzzle of the issue. And interesting though, that on the right-hand side, it's increasing the energy use, as you see in these graphs. Well, in some parts, and as they increase, the higher the energy use is in countries where the buildings are really representing most or the most important percentage of the total energy use. So that's in their worst situation. So the solution, though, are there both in terms of really providing the appropriate environment. And when we accuse buildings, let me tell you, it's not the buildings, it's us. It's because of the occupants, because of the people that we want to satisfy our comfort conditions and then have proper air quality. And that altogether means that we can, using in a smart way, the best possible way, the energy to provide and optimize our indoor environmental quality, which incorporates all the different aspects. Now, we get a lot of concern over the past few years because we went through the hard times of COVID. Everybody was up in their toes of what type of air are we breathing? What type of environment are we in? So we got very concerned about all these operations. Somehow we have the solutions, we have the answers, and we want to stay away from the buildings getting sick because we get sick. So that altogether kind of presents the issues, presents the challenges that we want to face. So that's the operational problem. You know what's coming up and now putting on our radar screen even more? That even before we move into the building, even before we crank up the air conditioner or whatever, in terms of using energy, we have used a significant amount of energy because we have the so-called embodied that goes into the materials, goes into the equipment, from the extraction of the raw materials down to delivering and installing in the building. So that issue is attracting a lot more attention. It's becoming more important because we will see we have the solutions for keeping the operational side down in terms of the energy. So that is surfacing and is attracting more attention. Where we want to end up, it's in every step of the process, from the extraction of the raw material down to coming to the construction site. There are ways to improve the processes, and then as we move into the life cycle, and that becomes more and more important on how we actually perceive our buildings throughout their life, that may be 50, 60, 70 years, several decades, that we will be replacing certain pieces of the installation equipment and so forth. So we also have not only the initial, but the recurrent embodied energy. And then when you think of energy, of course, you're thinking of environmental impacts because they go together, especially because of the mixture of the energy that we have been using. Buildings is a big deal when you're talking about controlling the energy use, because right now the numbers are about 37% of the total, let me say it again, of the total energy that we use is because of the buildings. That's the biggest sector, the most important sink of energy is the building sector. Using energy, having an environmental impact. We're talking about environmental impacts. We're talking about greenhouse gas emissions. Well, about a quarter of that impact is associated to the buildings. And it's both because of what we're doing on site, on the building, because we burn fossil fuels, we burn oil, natural gas, but also because of the electricity that the buildings use. Because again, to generate electricity, you may be using fossil fuels. That together then brings the total 27. It even goes higher if you think about the emissions of the construction industry in terms of constructing our buildings. So altogether then, that can bring the numbers to about 40% of the greenhouse gas emissions related to the buildings. Well, what does that tell me? Well, we have really a lot to think about. Yes, indeed. So that is kind of like, that's part of the solution now, that our buildings, if we have an impact of that, we can address, resolve the problems. That's the good news in terms of how now the buildings can transform and contribute in our effort and path towards, and you've heard it so many times, I'm just putting here the figure so you know where we have been since 1990 in terms of the emissions, and that we are on a downward trend. Well, that looks good, right? There is progress. Thumbs up. We should be actually satisfied with what we have been achieving. And then with the red line, you see the targets. You see that we are pushing it down and down and down towards, in a couple of decades, the so-called decarbonized continent, decarbonized Europe, decarbonized sectors, decarbonized buildings. That's where we're aiming. Not zero, net zero, which means, well, we're going to be emitting something, but we would be minimal, and then we will have ways to absorb, remove from the atmosphere what we're emitting, so the net will be zero. That's where we're aiming. Easy to do? Well, things are going to get tougher as we move on. And look at the latest recommendation that came from the EU Parliament a few days ago. They're proposing that we move our target a few not years later, but earlier, actually suggesting that we hit 90% reduction by almost the day after tomorrow, by 2040. That would be very ambitious. I don't know if it's going to fly. I really don't know. But at least with that information, one of the decision-making bodies in the European Union, you see that it's aiming to even move faster. Again, we don't know which way because you have other decision-making bodies that need to agree and comply with that because of the things, how they work. But this is really showing us that our targets remain on the top of the decision-making sectors. One of the things that I want to make sure that everybody, when we leave this room, is clear about that there are different policies, really a lot of different elements. And we have, when we talk about buildings, we have the trilogy of the energy efficiency that should come first, is really the motto of the European Union, and actually I would say should be the motto of all of us when we're dealing with our homes, that energy efficiency is the first priority. Then you have also the Energy Performance of Buildings Directive that really is the flagship directive that relates to buildings, and you also have the Renewables Energy Directive. That together constitutes only elements of the bigger puzzle. So we do have a variety of policies, and we want to make sure that we recognize the importance of really working and having different instruments and policies, which is important. We have to be aware of the evolution, and as you see, targets change. I like that expression about the river and the water. Things are changing. Hopefully, they are changing in a way that we can keep up to pace. And if we do not act, guess what? Things are going to get even harder in terms of the immediate future. In terms of how fast we need to move, here are a few indicators of the Energy Efficiency Directive of the past few years of saying, well, we need to actually drop down in terms of, or improve efficiency over 1%. Don't think that, only 1% per year. Don't think that's an easy target. That's a very difficult target to achieve. And as we pick up speed, you see, towards the mid-20s, approaching the end of the 2030 target, you see we approach at 2% per year. So we need to get really more aggressive in achieving this. You want to take a glimpse of what's coming up in the future? We're talking a lot about electrification and using electricity. Well, this is how the electricity mixture is going to look in the near future. It's going to be green. So whenever you hear the efforts and say, yeah, well, how are you going to generate this electricity? The idea is that the generation would be mostly from renewables. And then as we move down to the end uses, you see the impact and the relation. You need to squeeze down every sector, contribute to this effort to minimize the energy use in order to be able, with the renewables, to generate and then also resolve the issue of storing it and being able to manage the electricity. Now, enough about, I can see the challenges, I can see the problems, but, well, do we have any solutions? Do we have any answers? Yes, we do, and that's really the good news. But you see the last letter that I have on this term, solutions, meaning they are more than one. Don't ever engage in a discussion when someone says, I have the solution for you. It's the best thing. That's what you need. It's probably not telling you the truth. Don't ever fall in the catch that someone says, this, what you're doing, it's not going to work because blah, 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 blah. Because why? Because there's different solutions that they need to work together. Do not engage in saying, well, there's never going to be enough electricity to use and use it in the way we're using today. True. That is impossible. It's not a good idea to use the electricity today to electrify everything. We cannot do it. But this is only part of the answer. They're interlinked. There are several things. The challenge we have is to really unveil and reveal what are the options. And you know, we have been making some good process. Finally, after years, we have the new normal. We have the minimum requirements. They're set up as standard practice. That's the key of the success of the legislative measures. EPPD, the Energy Performance of Building Directive, at the European level, and then at national level, our regulations, our codes. Finally, they're taking us through the basic steps. Finally, what we have been preaching, and I recall so many presentations, so many discussions from the universities, from the conferences of saying, well, we need to minimize our loads. We need to really start from the envelope. We're doing this as common standard practice. Then we're moving to using more energy efficient equipment. Thank God the industry has been responsive, is putting out and it's improving the efficiency of the equipment. And then renewables. That makes sense, even financially speaking, once you have decreased your demand, then with the renewables, it's feasible, economically feasible, to actually satisfy what the buildings need. And guess what? Once we have been doing this, then the buildings are also resilient. So they can withstand the obstacles, the issues as a result of the climate change, of the climate crisis, the extremes that the buildings are exposed to. They still need to provide and satisfy the occupants in healthy indoor environment, a comfortable indoor environment even under these obstacles. The baby steps, finally, what we have been preaching and saying, it's there. Minimum requirement, even from the requirement that different disciplines of engineers must work together, from the architect, the mechanical engineer, the civil engineer, and not have the process from the old days that the architect will get the concept, the civil engineer will make sure that the building will stand, and the mechanical engineer will come in to fit in the equipment to the space they left in. They work together, and that really, from the beginning, with the principles of bioclimatic design, that's minimum requirement. Think about it. Maybe it's not going to work in your building, but at least consider it. Then really take care of your envelope and then your mechanical installations with the minimum requirements. That's all, again, the new normal. So, well, okay, case solved. Are we done, finally? No, not really, because that's for the new buildings or the renovation of the existing buildings. This is the big challenge. That's the gorilla in the room, as we say. This is actually the monster that we have to deal with. The millions of buildings, the billions of floor spaces of where we're actually hurting and bleeding. How can we actually transform from our cities to problematic buildings, existing buildings, to green buildings? Is it possible? Well, yeah. But again, the big issue, the big challenge is the euro symbol or whatever the currency is how you're going to cover the cost for all this. Now, because as we say, things are changing and we need to stop talking about it and doing it, one of the new requirements that the revised Energy Performance of Building Directive has brought up is the minimum energy performance standards. What does that say? Well, over the years, you have been learning about your buildings. You have the energy performance certificates, you have the labels, so you know where your problems are. Okay, enough talking, start doing something. So the new directive is gonna really ask the member states to implement and start from the bottom up, from the worst performing buildings, to actually do something renovate them or take them out of use. That's going to change because what are the worst performing buildings? That's where people are really probably cannot afford to do the renovation. So you start seeing the complexity now. So we'll need new instruments, financial instruments, new solutions. But the requirement there is you need now, not as an option, not as a recommendation, but as a mandate to renovate. I'm going to walk you through the basics. I'm going to remind everyone that we have solar. We have trillions of energy available, at least during the day, that we can use, and we have been using it to heat our water. Well, even that, to small to the big scale, we're still, and look at that picture in the center where I have the question mark, saying, well, even today, we're doing such a foolish things. Look at the solar collecting, looking where? Looking at the wall. So imagine, and you see the building, it's a new building. It's not an old installation. So sometimes it takes situations like this to realize that even the basics need to be addressed properly. You have more needs, then you have more solar collectors. It works that simple. And once you have more solar collectors, what's the next logical thing to think about? Well, not only your domestic hot water, but also use it for space heating. So that, with regard to the solar combi systems, has been working. Simple designs is just at a bigger scale. You need your solar collectors, you need your storage. Always remember, every time you use renewable energy, you need storage. So that's the minimum requirement. And from there on, you can use it with different types of installations. Again, the basic baby step, minimize your demand so that it's more financially attractive, and select wisely your systems like subfloor heating systems that use with lower operating temperature. That makes sense. Well, I want more. Can we do more? Yeah, because we also have cooling. And solar energy, solar thermal has been, and the knowledge is there, the systems are there, the technology is there for centuries. This is not something new and sexy and say, oh, wow, I can use solar heat to also produce cooling. Yes, you can do that. So you have now a more complete combo system, which is Combi Plus, where the difference is in the layout there that everything is a little bit bigger. So you have more solar collectors, you have more storage in order to also drive your piece of equipment. That's the unique new part now, the heat-driven cooling system. Now, the interesting part of this is that you have that demand where your cooling is needed. So you have cooling when solar radiation is at its peak, so perfect match. And actually now you solve the problems with your solar collectors that during the summer actually is a problematic operation. You may have stagnation, so that solves you the problem. And the beauty with the different technologies of for cooling is that we have absorption. As you see here, the market is kind of like dominated by this kind of technology, but there are also other solutions. Now, out of this, what do you get? You get your cooling during the summer, then you can also use the same installation, financially speaking, that's attractive, that also for heating. The breakdown, as you see on the right-hand side, actually the added part with the cost for the chiller, for the absorption chiller, you see it's about 15 to 20%. It's not the big deal. The biggest part is for solar collectors because you have a solar field and the hydraulics. But you know what the biggest obstacle is? That we don't feel comfortable with this type of installation. I haven't done it yet, so I'm not going to think about it. So reluctance because of the lack of a little bit of experience there, and the first cost is something that needs to be addressed. Now, we're getting crowded up there on the buildings because solar collectors, more area, more field, where do you put it? So the architects start thinking, well, I'm going to use them as an integral part of my building. So you see on the center of this slide, vacuum tube solar collectors that are used as a pergola over the flat roof. The roof is primarily occupied by your solar collectors at a bigger scale. Even aesthetics can really work out. And then once you have all this in several buildings, then you can start thinking about seasonal storage at a bigger scale in order to be able to cover the operation. And once you start thinking, well, I'm done, right? No, because photovoltaics is the other contributor, the other very attractive technology for both as a building material and also for power generation. In the previous slide, I have that you can use PV-generated electricity directly now to drive your air conditioning. So they can come as a package. And once you're thinking about, okay, solar thermal, photovoltaics, am I done? Well, now some people are thinking, well, let's squeeze in there and integrate it even wind. That takes it a little bit to the extreme in terms of also the architectural side. You don't see too many of those yet, but what I want you to start thinking about is that you have different options. That's the main key information that we want to keep. From the basics, we also have lighting. So as soon as you have solar radiation, you have daylight. That's also very important in the approach, especially for the architects, but also us as users. When I first walked in, now of course we adopted, the room was so appealing because there was the daylight coming into the room. So as humans, we love the interaction with the daylight. And then we have solved also the other problem, what do we do with the artificial lighting? Because always your buildings need artificial lighting. So there we have also have the answers. And then the challenge is how do you optimize the use of daylight with artificial lighting, the controls, so that we have the optimum levels of desirable, or the light tubes that actually solve the challenge. Yeah, sure, you can do that once you have spaces in the outer perimeter of a building, but what do you do in the core? So there, the light tubes, for example, can actually bring in daylight of sufficient quality and quantity. And completing the basics, in terms of our appliances and equipment, we have another landmark directive, eco-design, that's actually, among other things, for everything that is out there in the market today, they need to comply with minimum requirements. For the TV or the refrigerator and the white appliances we have at home, down to the pumps and the fans and the chillers and the boilers and the heat pumps. This is one of the most influential directives that we have in Europe to finally clear the market, to finally make it easier for us as engineers to not have to argue of what's available in the market. We know it's good, energy efficient, quality equipment material that we can use, and also as users. And especially with the standby power, there has been tremendous progress in terms of, again, the manufacturers responding and putting out equipment that we can put in our homes, in our offices, that will not cost us more. What do I do with the existing buildings? Can you tell me? Well, I'm not going to tell you because it's all there. It's all there, written for years and decades. And I have here the excerpt from one of the really very popular publications, ASHRAE Standard Energy Efficiency in Existing Buildings, that has information and ideas of what you can do. Why don't you do it? Well, yeah, Costas, let me tell you, they cost. So are you going to provide the financing? Well, that's the task. That's the task, and as engineers, we need to make sure, and that's our job, that's our responsibility, to prioritize what for our specific building, not out of blindly picking up, my fellow engineer next door did this and this and that. That's what I'm going to do. It worked for their, well, it may not work for your building, so make sure that you do this balance and you look at the benefits and the cost. Well, now the whole industry is changing, and as I complete this overview of the cosmos of the building, I like this big picture where it's telling us from the design to the building material, to the on-site 3D printing, there's such an evolution. And the more computers, the more computational power we'll have, will give us more tools to address these complexities, to really have and know from day one down to the operation of the building and how this interacts, all the information that we need. From our design, and if you are in the design process of building and so forth, things are getting more and more powerful in terms of using BIM, and what the information is right there at our fingertips. Not just layouts, not just 2D, 3D, but as you see with all the additional information about cost, operation, sustainability, and safety. So the cosmos of how we design our building is really changing to the better. But a tip of advice, let's not get overexcited. Let's not make it overcomplicated, especially at the design. Let's keep it simple, well-targeted, in order to be able to maintain it, in order to be able to sustain its operation. And actually, once we do that, well, then we will be able to actually gain the benefits. One of the upcoming, and if you haven't heard it, about that our buildings are really going to be assessed not only in terms of their energy performance, but also of their IQ, of how smart and how smart ready are our buildings. So the smart readiness indicator has been in the pipeline. It has matured over the years. It's ready to actually be released from the European Commission and be integrated within the next probably EPBD as a minimum requirement. It has been introduced already. It's out there. It's being tested as we speak in several European countries that actually is assessing the overall performance of the building in every different end-use sector. And it's actually telling you how good or how ready is your building to be and play in the big league, in terms of being interactive. And once we understand what the future will bring in terms of our buildings, in terms of being efficient, being connected as a result of electrification, being smart and flexible in order to, again, be responsive to our needs as occupants, or what the grid requires so that you go in and out. We had the example before saying, well, now the prices are going down, or it's a negative price. Well, then you fire up some of your electrical equipment, or you give the opportunity to the grid operator to take out some of your equipment when there is a need, because when you have the variability of the renewables, that's the only way you will be able to maintain the stability. So from the smart buildings, where we're going to go, and that's where we complete our trip, we're going to go to the smart cities. Hopefully, we're not going to forget the smart people, because the smartness probably begins with us as engineers, designers, but also in the cities that we live in. All the different elements of the puzzle need to be there in order to be able to be more responsive. But one of the key elements in building this new reality is a smart and efficient buildings. From there on, we can address and look at the different elements of this. Well, this is probably the biggest message I want to give all of my colleagues, all of my engineers, either as you think, as your role as a professional, as a citizen, and also as an individual. We can make a difference. So I'm challenging you, let's start from this congress, from this conference. Let's exchange and let's learn from each other, and let's make sure that when we go back to our home, when we go back to our office, we think globally, but we act locally. Thank you.
Zahvaljujem se profesoru Balarasu na ovom dinamičnom i interesantnom izlaganju. Trenutno na Mašinskom fakultetu u Beogradu šef katedre za termomehaniku je profesor Miloš Banjac. On predaje termodinamiku i prenošenje toplote i mase kao osnovne predmete. Bio je više godina pomoćnik ministra za rudarstvo i energetiku. Radio je nekoliko strateških projekata iz oblasti energetike Republike Srbije i član je Odbora za energetiku Srpske akademije nauka. Kolega Banjac, imate reč.
Uvaženi predsjedavajući, hvala na predstavljanju. Poštovane dame i gospodo, u skladu sa light motivom ovog današnjeg, ne današnjeg, nego ovogodišnjeg KGH, ja sam odlučio da probam u svojoj prezentaciji da predstavim kakvi su to budući koraci, šta čeka i kakva je uloga KGH sistema uopšte i sistema grejanja u budućem okvirima i u budućnosti koji nas čeka u sledećih 10 ili 30 godina i kakvu to transformaciju treba da se uradi. Ujedno čestitam i prethodnim govornicima na stvarno inspirativnim prezentacijama. Mi imamo malo različite polazne tačke. Vi dolazite iz zemalja koje su napravile već mnoge korake koje mi još nismo, tako da u tom smislu moja prezentacija će biti malo drugačija, da kažem malo tvrđa, šta mi to tek treba da uradimo da bismo dostigli vaše nivoe. Naravno, dopalo mi se to da treba da mislimo i da ne čekamo ono što, zakonsku regulativu, da nas ona usmerava što da radimo, međutim, mi smo u poziciji da mi tek čekamo zakonsku regulativu da bi dostigli neke nivoe, a tek posle toga da idemo i korak napred. U jednom delu će prezentacija biti preklopljena sa prezentacijom profesora Balarisa, zato što ja upravo pokušavam da kroz ove 4 direktive koje za nas još nisu ni obavezujuće, pokažem šta nas to čeka. Mislim da je ovo smer za napred, nije. Centralno dugme. Dakle, pokušat ću prvo da predstavim kakva je to globalna situacija, zbog čega sve ovo radimo, malo poduži uvod, zatim koje su to politike koje nas vode i koje će voditi energetsku efikasnost, ali svakako i KGH sisteme i sisteme daljinskog grejanja, kakva će njihova uloga biti u dekarbonizaciji sistema i zatim predstaviti ove 4 direktive koje su okosnica te transformacije u formalnom smislu, a zatim i ono što bi mogli mi da uradimo, ono što bi vlada mogla da uradi, što su budući koraci, kao i koji su to inženjerski izazovi implementacije ovih direktiva. Dakle, mi počevši od, mi globalno, dakle, ceo svet, počevši od te prve industrijske revolucije od 1850. godine, drastično je povećalo emisiju ugljen dioksida. Posljedica toga su globalne, dakle, imamo i promenu globalne temperature, ali i klimatske promene. Na ovim slitkama vidite kakva je to promena, dakle, u pitanju su milijarde tona, 40 milijardi tona CO2 koje sada emituju, a koje pre svega 150 godina nismo emitovali. Taj trend, nažalost, je sve veći i veći. Na slajdu sa desne strane možete da vidite da Evropa i razvijene zemlje smanjuju tu potrošnju, dok zemlje Kine, Indija i Dalekog istoka imaju povećanje ove potrošnje, tako da globalno svi rastemo. Što se tiče proizvodnje energije, kada govorimo o primjernoj energiji, svega 14% je te energije bilo 23. godine iz obnovljivih izvora energije, ako tu računamo naravno hidroenergiju kao klasičan izvor energije i sve ove ostale, vetar i sunce. Još uz 4% nuklearne energije kao energije koja je oslobođena emisije CO2, sve ostalo je na uglju, gasu i nafti, dakle sa velikim emiterima ugljen dioksida. To, kao što sam rekao, izaziva promenu globalne temperature. 2015. godine bio je čuveni klimatski skup u Parizu gdje je dogovoreno da će bogate zemlje napraviti jedan fond kojima će finansirati i ove siromašnije da bi mogli da se uklope u taj sistem borbe protiv klimatskih promjena i smanjenja emisije ugljen dioksida. Međutim, bez obzira na taj dogovor i na obećanja, ova prevojna tačka još uvijek nije prevaziđena. Dakle, mi i dalje sve više emitujemo globalno, dakle, ceo svet sve više ugljen dioksida i nikako dođemo do te prevojne tačke da počinjemo da smanjujemo emisije. Tu su razne politike, razne obećanja, ali već, odnosno još prošle godine, 2024. godine, mi smo prevazišli ono što je trebao da bude maksimalna temperatura za 2100. godinu, a to je povećanje temperature od 1,5 stepen Celzijusa do 2100. godine. Mi smo 24. znači već to premašili, tako da bi sad trebali da uradimo čak i mnogo više da dođe do smanjenja temperature, što je verovatno nemoguće. Kada gledamo, bar mi u Srbiji tako, i kad govorimo o tome kako treba da promerimo energetski sektor, uglavnom se misli na elektroenergetski sektor, pošto je to jedan od naših najvažnijih sektora i naš je, dakle, u potpunosti i imamo izvore, do sada smo imali sve izvore za električnu energiju i za pretvaranje, tako da smo se nekako koncentrisali baš na taj segment. Međutim, zaboravljamo da polovina tog energetskog sektora u stvari čini i sektor za grejanje. Ovo su podaci globalni, dakle, za ceo svet, kakva je raspodela proizvodnje toplotne i električne energije i energije, odnosno potrošnje energije u transportu. Kada govorimo o Evropi, otprilike je slična situacija. Što se tiče energije za grejanje, ona se uglavnom koristi ili u industriji ili za grejanje, dakle preko 50% te energije za grejanje i hlađenje. Konkretno, veći deo toplote naravno proizvodio se iz fosilnih goriva i dalje je takva situacija, mada su trendovi da se taj udeo smanjuje. U ukupnom tom miksu energije, električna energija i sistemi daljinskog grejanja čine 21% energije, što je svakako potencijal koji može u potpunosti da se prevede na obnovljive izvore energije. Osim toga, dakle, posmatrajući efikasnost grejanja i hlađenja, kada pogledamo ove sektore za potražnju energijom šta se dešava u Evropi, vidimo da najveći deo te energije za grejanje i hlađenje odlazi na sektor za domaćinstva, dakle, industrija jeste značajan udeo u tome, ali domaćinstva i ovi servisi takođe predstavljaju veoma velike potrošače te energije. I još samo jedna od ovih uvodnih činjenica, dakle, prema Međunarodnoj agenciji za energiju, operativna potrošnja energije u zgradama čini oko 30% potrošnje, ona se čak penje na 34%, ako gledamo i ono sve što ide uz gradnju tih objekata, a prema našem nacionalnom energetsko-klimatskom planu, dakle prema zvaničnim podacima Srbije, 45% ukupne finalne energije troši se u sektoru zgradarstva. Kada gledamo sada deo koji se tiče konkretno hlađenja, broj stepen dana uzrokovan klimatskim promenama i povećanjem globalne temperature rašće. Dakle, ovo je bila situacija, prosečni broj stepen dana hlađenja od 2007. do 2017. A do 2050. očekuje se da će se 25% povećati taj broj stepen dana hlađenja, samim tim i potrebe za hlađenjem sistema. I dalje se u oblasti hlađenja, dakle, ovo je bio trend povećanja hlađenja do 2016. godine, 1990. do 2016. Taj trend će se dalje nastaviti, a predviđenja su da će se taj trend čak toliko, da će se utrostručiti energija koja će se trošiti za hlađenje do 2050. godine, odnosno na 2016. godinu. Dakle, veliki su izazovi, bilo da se radi o tome da smo u sektoru domaćinstva, bilo da smo u sektoru komercijalnom. Kako smo se do sada branili od prevelike potrošnje energije i povećanja potrošnje? Pa tako što smo imali neka tehnička rešenja koja su sama po sebi dolazila, odnosno u kome su inženjeri svojim tehničkim domišljatošću dolazili do toga da povećavaju, ovdje imate prikaze koja su to osnovna tehnička rješenja bila koja su povećavala kako koeficijente grejanja, tako i koeficijente hlađenja. I dosegli smo prilično zavidni nivo. Naravno, postoje i dalje mogućnosti da se uradi nešto na tom pitanju. Postoje unapređenje komponenti sistema za klimatizaciju, nekoliko u najavi mogućnosti, kao i neke nove tehnologije, sistemi bez kompresije pare. Dakle, to su još neke dopunske mogućnosti, ali to dovodi do teorijskih, sada već limita, kada više ne možemo u tehničkom smislu ništa dalje uraditi na samim mašinama koje nas obezbeđuju da bi sproveli to grejanje, odnosno hlađenje. Ono što ćemo koristiti u budućnosti, to su naravno veštačka inteligencija i IT tehnologija, zato što će one, a to su sve ove mere, ne prva ni poslije, nego ove između, koje će nam omogućiti da što kvalitetnije i u pravo vreme koristimo kako izvore energije, tako i da zadovoljavamo naše potrebe. I iskoristio sam jedan poseban slajd da kažem šta to sve može da bude. Dakle, prediktivna regulacija prema spoljnim uslovima, adaptivno upravljanje kompresor, optimizacija defrost ciklusa, dinamičko upravljanje, učenje termalne inercije, optimizacija rada ventilatora i pumpi, multizonska rekuperacija, integracija sa solarnim sistemima, baterijama i celom mrežom. Dakle, to je nešto što nam može doprinijeti veštačka inteligencija. Ona će u tom smislu ne podići koeficijent grejanja i koeficijent hlađenja, ali će podignuti sezonske koeficijente grejanja i hlađenja za 0,5 do 1%, ali to će u ukupnoj potrošnji energije biti nekih 15 do 35%. Pored toga, ono što je globalni proces jeste da se primenjuju makar trenutno najsavremenije tehnologije. Dakle, ako bismo pogledali kako će biti razvoj i koliko će biti potrošnja, odnosno ušteda u energiji, ako gledamo da bi sada zadržali ove tehnologije i ovu neravnomernu raspodelu po svetu primjene tih tehnologija, imali bi ovaj dijagram sa leve strane, a ako bi se svi primenili standarde, minimalne standarde za energetsku efikasnost, ali trenutno postojeće, taj svakako porast efikasnosti bi bio značajno veći. Na ovim slajdovima su upravo prikazani ono što nas očekuje ako budemo primjenjivali minimalne standarde efikasnosti. Profesor Balaras je nešto pričao o tome i ja ću to malo još dopuniti. Što se tiče primjene tih standarda, ovdje imate sa plavom bojom označene zemlje koje ih primenjuju i one koji ih ne primenjuju sivom bojom, odnosno koji su obećali da će da ih primene. Malo ću da uvećam ovu sliku Evrope, pa ćete vidjeti da smo mi u načelu rekli da ćemo to da uradimo, ali nismo to primenili. O čemu se tu zapravo radi? Kažem, bit će u narednim slajdovima, da se držimo tehnologija koje su takve da imaju minimalno dozvoljene standarde za konkretno COP ili za sezonski stepen hlađenja i grejanja. Kao međuzaključak, dakle, tehnička rešenja mogu da doprinesu i doprinosila su do sada veoma mnogo smanjenju potrošnje energije, ali mi sada moramo preći na ove političke mere, dakle da primenimo sve ono što Evropa već primenjuje, da bismo i mi uhvatili u trku sa smanjenjem potrošnje energije i došli do tog nekog cilja ili se približili tom cilju koji Evropa zacrtala da do 2050. bude CO2 neutralan kontinent. Šta nas obavezuje prema tome da to moramo da radimo, što smo potpisali da ćemo da uradimo, a bojim se da ne radimo baš previše. 2006. godine mi smo, Skupština ratifikovala ugovor o osnivanju energetske zajednice. Pripremajući ovu prezentaciju shvatio sam da je u stvari to bilo 2005. godine, a sada je 2025. Znači nakon 20 godina plaši se da smo u tom trenutku bili bliže evropskim standardima i evropskim zakonima nego što smo danas nakon 20 godina, jer kao što ćete vidjeti, sve direktive koje je Evropa donosila u međuvremenu, mi smo se otprilike zadržali na prvom setu tih direktiva iz neke 2010. 11. godine. Sva nova rešenja koja su direktive predviđale, takozvani recasti, nisu primenjeni u Srbiji. Pored sporazuma o ratifikaciji ugovora o osnivanju energetske zajednice, naravno mi smo 2008. potpisali sporazum o stabilizaciji i pridruživanju, a 2012. smo dobili status kandidata i tu smo kao trebali intenzivno da se pozabavimo svim sektorima, a naravno i sektorom energetike. Potpisali smo i Pariski sporazum 2015. godine. Evropa je 2019. napravila jedan novi koncept, takozvani Green Deal, zeleni dogovor o tome da će postati CO2 neutralan kontinent, a mi smo 2020. samo godinu dana nakon toga također potpisali zelenu agendu za Zapadni Balkan, što u stvari predstavlja isto ovo što je rekla i Evropa, samo primenjeno na našem području. I sada dolazimo konačno do ovih direktiva koje, ako smo već prihvatili i da smo članica energetske zajednice i sve ove dogovore u međuvremenu i otvarali klastere čak i za energetiku, a nikako da ih zatvorimo, mi smo, što se bar tiče sistema za klimatizaciju, za daljinsko grejanje, u obavezi da primenimo ove 4 direktive. Naravno, krovna direktiva je o energetskoj efikasnosti i namjerno sam pisao ovde 2012. je prvi put doneta, 2018. je unapređena, a 2023. još jednom unapređena. Direktiva o energetskoj efikasnosti zgrada kreće iz 2002. pa 2010. pa 2018. pa 2024. nova direktiva, odnosno poboljšana direktiva sa novim ciljevima i novim zahtjevima. U ovom konkretnom slučaju mi smo i dalje na 2010. Red 3 direktiva, direktiva o obnovljivim izvorima energije, samo je ime kaže, treća je po redu, mada možda su umetne još jedna četvrta između, koja nije tako velike izmene imala. Mi smo i dalje, bojim se, na ovo iz 2009. Dakle, to je ono što smo transportovali u domaće zakonodavstvo. Direktiva o ekodizajnu četvrta po redu, ona propisuje te minimalne standarde opreme, 2009. 2018. i 2023. svaki put sve strožiji i standardi. Sve ovo govorim zato što smatram da, pored prelaska elektroenergetskog sektora, deo grejanja iz zgrada, odnosno sistema za klimatizaciju i grejanje, predstavlja drugi najvažniji element naše energetske transformacije. Videli ste na prethodnim dijagramima da je to najveći sektor potrošnje. Bez obzira što bi elektroenergetski sektor potencijalno mogao da pređe na obnovljiv izvor energije, ukoliko sa njim ne usaglasimo sektor daljinskog grejanja, samo 2 podatka, elektroenergetski sektor otprilike sada ima oko 8 teravata instalisane snage. Samo sistem toplana u Srbiji ima oko 6,3 teravata instalisane snage. To su dakle približno isti brojevi, pri čemu sektor daljinskog grejanja čini 30% od ukupne energije koja se troši za grejanje u Srbiji. Dakle, potrošnja energije je enormno veća, naravno ti sistemi, ovo je bilo poređenje po snazi, ne rade sve vreme tokom godine, pa zato i u ukupnom bilansu nije takav odnos. Par reči o svakoj od direktiva, na što nas one usmeravaju, a onda šta bi to mi u Srbiji trebali da radimo. Dakle, direktiva o energetskoj efikasnosti, krovna direktiva, definiše ciljeve, daje definicije politika koje države članice moraju da doprineti smanjenju potrošnje ukupne energije. Obavezujući cilj je postavljen u posljednjoj direktivi, nju citiram, dakle to je 11,7% smanjenja energije koja je predviđena za potrošnju energije u 2030. godini. Dakle, uvodi se obavezujući cilj, do sad su sve to bile onoliko koliko države obećaju, naravno da ih Evropska komisija, u našem slučaju Energetska zajednica, usmerava koliki ti ciljevi treba da budu. Prilikom punopravnog usklađivanja mi ćemo morati da prihvatimo i ovaj cilj o smanjenju potrošnje energije. Što se tiče godišnjih stopa, to je već bio slajd o tome, za Srbiju način da ovo ostvarimo jeste korišćenje sistema energetskog menadžmenta koji je već uspostavljen u Srbiji, doduše dosta ranije nego što je to Evropa tražila, posebno u javnim zgradama kada, znači, taj sistem energetskog menadžmenta postaje ključni mehanizam kako možemo da ostvarimo ove ciljeve, ne samo što se tiče ciljeva, nego što se i tiče monitoringa i izveštavanja. Proširena su pravila za javni sektor mora da štedi 3% energije, odnosno mora da se renovira 3% površine javnih zgrada svake godine. Mi smo se obavezali da ćemo raditi 1%, naravno pri konačnom usklađivanju morat ćemo i da prihvatimo ove daleko strožije kriterijume. Što se tiče sistema daljinskog grejanja, mi smo nekako jedva došli do toga da izbacimo naftu, da izbacimo mazut i ugalj, a da pređemo na gas, međutim, korišćenje fosilnih goriva mora da se isključi i mi u tom delu ćemo imati velike napore da to sada pređemo na obnovljive izvore energije i korišćenje otpadne toplote, da bi i taj sektor bio potpuno dekarbonizovan. Što se tiče grejanja i hlađenja, takođe predviđeno je potpuno isključivanje, faza isključivanja fosilnih goriva, a što se tiče finansiranja koje smo imali u sadašnjim projektima, to su od IPARD-a, od KFW banke, IBRD-a, EIB-a, dakle oni će prestati da finansiraju sve kotlove i zamenu kotlova na fosilna goriva, tako da će ono što treba da nas, s čime ćemo se susreti, to će da finansiraju verovatno samo korišćenje obnovljivih izvora energije i korišćenje toplotnih pumpi. Predviđena je kroz ovu direktivu energetskoj efikasnosti i obaveza mapiranja otpadne toplote, kako bi ona mogla da se koristi kod toplotnih pumpi i kod sistema daljinskog grejanja. Daljinsko grejanje naravno mora postati nisko ugljenično. Uvedena su i nova pravila o energetskom siromaštvu, mi u Srbiji time se nismo bavili, tako da to moramo da tek definišemo. Što se tiče naplate i merenja potrošnje, to moramo dakle da koristimo napredne sisteme. U prošle godine, čini mi se, bio je pokušaj elektroprivrede da pređemo na naplatu potrošnje na 3 meseca. Vidimo sad priličnu zbrku u elektroprivredi da očekuju da sami korisnici električne energije očitavaju svoja brojila. Napustili smo jedan dobar sistem mesečnog očitavanja, sad smo prešli na nešto novo, što je svakog korak unazad. Naravno, sve to mora da bude transparentno, da se vidi na računu šta se dešava i ovo se, još jednom ponavljam, uklapa sa jednim sistemom, dakle, informacijnim sistemom energetskog menadžmenta koji trenutno razvija, a i već u primjeni od 2013. godine u Ministarstvu energetike, da svaki objekat koji je u javnom vlasništvu mesečno izveštava Ministarstvo o potrošnji energije i vode. Osim toga, direktiva predviđa i takozvani sistem BIMS, dakle Building Energy Management System, koji traži da svaka zgrada ima merenja, da o potrošnji električne energije, podatke u realnom vremenu, o tome da se sistemi za grejanje, hlađenje i klimatizaciju imaju potpunu regulaciju temperature, da se prave rasporedi i krive potrošnje, da bude potpuno automatizovan sistem, naravno da imaju automatizaciju i nadzor kao i analitiku potrošnje energije. Što se tiče druge direktive iz ovog paketa, to je direktiva o energetskim svojstvima zgrada. Rekao bi da je to osnovni zakon za regulisanje energetske efikasnosti zgrada u energetskoj uniji. On naravno odnosi se i na nove i na postojeće zgrade, govori o tome kako zgrade moraju da se pregledaju, koliko treba da ih se renovira i kojom dinamikom i naravno uvodi pojam zgrada sa gotovo nultom emisijom. Do ove posljednje direktive govorilo se o zgradama sa približno nultom potrošnjom energije, sada se ide na još strožih kriterijuma, to su zgrade sa nultim emisijama. Glavne oblasti regulacije su minimalni standardi energetske efikasnosti za zgrade, dakle tim minimum što mora da se ispuni, mora da se poboljšaju i nacionalni ciljevi i da se ide napravi putanja kada je u dekarbonizaciji, dakle uvodi se, kao što sam rekao, pojam zgrade sa nultim emisijama. Energetska sertifikacija zgrada treba da bude popravljena, mi imamo jedan prilično zastareli sistem kako vršimo energetsku sertifikaciju zgrada, moramo da uvedemo i način da se u taj monitoring uvede i hlađenje, a naravno i to koliko imamo obnovljivih izvora energije. Takođe definiše se ovom direktivom koliko zgrada mora da se renovira, kako da se one formiraju u određene grupe i kako te najneefikasnije zgrade do koje godine moraju da budu renovirane. Tehnički sistemi postaju sada, zajedno sa zgradama postaju jednu celinu, dakle zgrade se gledaju kao energetski objekti, a tehnički sistemi sastavni deo njih i naravno tu se definišu pravila sistema za grejanje i hlađenje koje moraju da ispune. U ovoj direktivi se ne definiše minimalni standardi uređaja odnosno te opreme, međutim kaže se da oni moraju da budu usklađeni sa direktivom o eco-labelingu, tako da se jedna direktiva tu drugu nadopunjuje. Naravno, predviđene su inspekcije sistema grejanja i klimatizacije i dekarbonizacija fonda zgrada do 2050. godine, kao i ostalo svih drugih energetskih sektora. Minimalni standardi energetske efikasnosti praktično govore o tome za svaku zgradu kolika je najveća dozvoljena primarna energija potrošnje kilovat-satu. Dakle, podsjećam, do sada smo imali finalnu energiju koju smo pratili, sada se to odnosi na primarnu energiju, dakle, automatski su uključeni i svi termotehnički sistemi u objektima. Kolika je najveća dozvoljena emisija ugljen dioksida pojedinih zgrada, minimalna termička efikasnost što je bilo i do sad, ali se zahtevaju da svi sistemi za grejanje, hlađenje i klimatizaciju imaju određenu efikasnost, da budu automatizovani i da imaju automatsko upravljanje. Konkretno za sisteme za grejanje i hlađenje i klimatizaciju moraju biti i visoko efikasni, moraju da zadovolje te minimalne standarde energetske efikasnosti, moraju da budu automatizovani, uvode se obavezni pregledi, dakle pri postavljanju, što je bilo i do sada, dakle pri instalaciji tih sistema vrši se kontrolni pregled da li rade na odgovarajući način, ali i godišnji pregledi su sada novina koji se kontroliše da li su sistemi izbalansirani i dobro podešeni. U Srbiji smo svesni činjenice da, recimo, sistemi daljinskog grejanja su veoma neizbalansirani, mnoge zgrade su pregrane, druge su hladne, istovremeno u okviru jedne zgrade, zato što se ne održavaju, odnosno ne balansiraju redovno, imam stanove koji su hladni, a drugi su pregrani, tako da sve su to mere koje će doprineti uštedi energije, ali naravno i boljem komforu. I kada se govori o neophodnoj integraciji obnovljivih izvora energije za korišćenje i sistema za grejanje i klimatizaciju, a kada se govori o takozvanoj dubinskoj renoviranju, dakle više ne možemo samo da menjamo fasadu na zgradama, nego treba uvek promeniti termotehničke sisteme, odnosno uklopiti ih u te smanjene potrebe za energijom, pri tome ti sistemi moraju da budu efikasni i po minimalnim standardima za energetsku efikasnost. Kada se tiče kotlova, radi se o tome da su zabranjene subvencije od 2025. za kotlove na fosilna goriva, što će postepeno dovesti do toga da se oni budu i potpuno isključeni sa sistema. Nisu dozvoljeni apsolutno za ove zgrade sa nultom emisijom. Što se tiče onog šta je dozvoljeno, naravno dozvoljene su toplotne pumpe, obnovljivi izvori energije, sistemi daljinskog grejanja koji su efikasni, odnosno koji koriste ili obnovljive izvore energije i koji koriste otpadnu toplotu. Što se tiče samog sistema daljinskog grejanja, može se koristiti u novim zgradama i postojećim, ali samo ako je efikasno, to znači ono prethodno otpadna toplota i obnovljivi izvori energije, fosilna goriva se izbacuje, sve zato da bi do 2050. bili potpuno dekarbonizovani. Sledeća direktiva je direktiva o ekodizajnu, već sam je spomenuo. Uz direktivu o ekodizajnu odmah spominjem i direktivu, odnosno eco-labeling regulaciju, pošto ona nije direktiva, nego je samo jedna vrsta uredbe, ali one se međusobno nadopunjuju. Sama direktiva o ekodizajnu govori koji su sve to kriterijumi koji su dozvoljeni da bi neki proizvod mogao da se postavi na tržište Evropske unije. U tom smislu definiše se kolika može da bude energetska efikasnost, kolika su ograničenja u emisiji i uvodi se obaveza naravno tog energetskog obeležavanja. Takođe, a to smo imali priliku i da vidimo na slajdu sa već četvrtom recastom od ove direktive, predviđa se postepeno pooštravanje standarda za svaki od ovih prethodno navedenih kriterijuma. Ekološki dizajn je takođe predviđen, dakle da se ti uređaji mogu popravljati, a ne da kad im prođe ili prvi put kad se pokvare da ih zamenimo, a opšti cilj te regulative je poboljšanje energetske efikasnosti proizvoda, smanjenje potrošnje resursa i emisija tokom životnog ciklusa. Još jednom samo da napomenem, dakle, ekodizajn direktiva je tehnička barijera za proizvode koje mogu da se nađu na tržištu, u ovom slučaju proizvode koje troše ili koriste energiju, pa u tom smislu tiče se i svih sistema za hlađenje, grejanje i klimatizaciju. Dopunska regulativa ekodirektive i direktiva je eco-labeling regulacija, koja sada dalje širi ovu priču o tome šta je dozvoljeno da se stavi na tržište, odnosno ona pojašnjava kupcima koliko je sada efikasan taj proizvod. Dakle, jedna ograničava, a druga kaže da li je ona i u kojoj klasi, pa je to obeležavanje od A do G, ranije je bilo A++ i tako dalje, to je sada izbačeno, mada kod nas i dalje su ovakve oznake na proizvodima, dakle, to moramo da, između ostalog i to da promenimo. Ovde sam naveo, ako neko bude posle pregledao tu prezentaciju, svi oni lotovi koji jasno definišu koje su to uređaji koji se podvode pod ovu direktivu, dakle gde se neki od ovih uređaja ograničavaju da budu po energetskoj efikasnosti svojim svojstvima na tržištu. Još jednom skrećem pažnju, nismo članice Evropske unije, dakle ovo za nas još uvek nije obavezujuće, postaje obavezujuće tek kad mi to prevedemo u domaće zakonodavstvo, znači kad se uvede prvo u zakon, a posle razradi pravilnicima. Za sad ovo nije obavezujuće, ali za nas bi moglo to da bude onaj korak unapred, odnosno za vas da pratite i ugrađujete energetski efikasnu opremu koja se odnosi na grejanje prostora, na grejanje vode, čuvanje tople vode, na čilere, na uređaje za klimatizaciju. Ovde sam izdvojio recimo jedan uređaj za klimatizaciju, šta to treba da ispunja, znači ne standarde, nego sezonske koeficijente grejanja, sezonske koeficijente hlađenja u određenim intervalima, koliko da troši energije u stand-by modu, da prilikom njihovog ispitivanja se obavezno koristi taj sezonski način određivanja COP-a i da ima ograničenja u radnim fluidima. Takođe, ventilatori, stand-by modovi, ukoliko troše energiju, sve pumpe, sve jedinice za ventilaciju, bojleri na čvrsta goriva, lokalni grejači, ali i električni motori i oni kontrolni sistemi koji kontrolišu sve ove uređaje. Dakle, potpuno i jasno je definisano i kao što je već rečeno danas, dakle, imamo jasna pravila koja treba da sledimo i koje uređaje možemo da koristimo, pa ćemo samim tim već ispuniti ove uslove i obarat ćemo potrošnju energije. Dakle, evo sam ovde kao mala podsjetnik, direktiva o energetskoj efikasnosti zgrada ne definiše ove stvari, to definiše direktiva o eko-labelingu, ali direktiva o energetskoj efikasnosti zgrada kaže samo ti uređaji smeju da se ugrađuju. Konačno dolazimo do posljednje direktive o obnovljivim izvorima energije. Ona se, kako mi u Srbiji gledamo, pre svega odnosila na električnu energiju, međutim ona se odnosi na grejanje i hlađenje. U velikoj meri moramo da promenimo sistem grejanja i hlađenja, naravno odnosi se na industriju i saobraćaj. Industrija se sama po sebi menja, pošto je ona većim delom u privatnom sektoru, pa oni prate i sve te smernice vezane za energetsku efikasnost. Nažalost, javni sektor se toga ne pridržava. O čemu govori direktiva o energetskoj efikasnosti? Pa definiše koji su to ciljevi koji moramo da bude u učešća obnovljivih izvora u finalnoj potrošnji energije, govori o promociji obnovljivih izvora u grejanju i hlađenju, daje podršku tehnologijama koje koriste obnovljive izvore energije, odnosno kako da se subvencionišu, kako da se koriste obnovljivi izvori, odnosno propisuje da moraju da se koriste obnovljivi izvori energije u grejanju i hlađenju, kao i u industriji, daje administrativne procedure za ubrzanje ovih procesa i daje predloge kako da se definišu garancije porekla za korišćenje obnovljivih izvora energije. Na jednom slajdu, dakle, direktiva o energetskoj efikasnosti je opšta direktiva, ali se odnosi na sve zgrade, industriju, javni sektor, grejanje i hlađenje. Direktiva o zgradama, naravno, odnosi se samo na zgrade, a ona opet uslovljava koji to sve uređaji što se tiče termotehnike mogu da budu uređeni, da moraju da budu automatizovani i da budu pod stalnim monitoringom. Ekodizajn, dakle, propisuje koji su to uređaji koji smeju da se stavljaju na tržište i kakvi su im energetski razredi, a direktiva o obnovljivim izvorima energije, osim što definiše ciljeve za obnovljive izvore, govori o tome kako naši sektori daljinskog grejanja moraju da pređu na obnovljive izvore energije i otpadnu toplotu. Sve u svemu, ove 4 direktive predstavljaju jedan skup propisa i pravila koja, ako se pridržavamo, dovešće do toga da imamo smanjenu potrošnju energije. Ono što je u svemu ovome dobro, da je neko drugi već napravio jedan, doduše komplikovan, ali funkcionalan mehanizam, i mogli ste da vidite i na prethodnim slajdovima, da Evropa smanjuje potrošnju energije, a upravo držeći se ovih pravila ove 4 direktive. Ponovo kao neko među zaključak, za ove 4 direktive fosilni kotlovi moraju da se izbace, moraju da se uvedu toplotne pumpe, obnovljivi izvori energije i da sistem daljinskog grejanja bude efikasno, odnosno obnovljivo, da sistemi za klimatizaciju moraju da budu digitalizovani, upravljivi i visoko efikasni i da daljinsko grejanje prelazi na otpadnu toplotu i obnovljive izvore energije. Sljedeća dekada mogla bi da bude ključna, ali bojim se da sam ovu rečenicu već puno puta ponavljao. Dakle, od 2005. 2006. bili smo dosta blizu svega onoga što se dešavalo u Evropi, jer i Evropa tada imala neko zatečeno stanje. Evropa je da ne treba da sumnjamo u ispravnost ovoga, govori činjenica da je Evropa u posljednje 3 godine uspela praktično da sa 45% zavisnosti od ruskog gasa i 30% zavisnosti od ruske nafte prestane da koristi i jedno i drugo, gotovo prestane da koristi jedno i drugo. Znači, oni imaju dobre mehanizme i dobro razvijenu strategiju kako to treba da se radi. Dakle, ne trebamo da sumnjamo u sve ovo. Šta bi trebalo da radi naša vlada? Pa naravno, trebalo bi da donese paket novih mera, što kroz zakone, kroz što strategije, dakle, nacionalni plan grejanja i hlađenja, što nikada nije bilo reči da se radi, strategiju za transformaciju daljinskog grejanja, mapu toplote Srbije, gde sve tu imamo otpadne toplote da bi mogli da iskoristimo. Kao primer, mada ga mi nemamo, recimo toplota iz metroa, sada se u evropskim gradovima počinje da koristi za grejanje, a ne više onako da se baca, odnosno u svakom slučaju mora da se rekuperiše ta toplota. Akcioni plan za elektrifikaciju grejanja u zgradama, zbog čega elektrifikacija, korišćenje toplotnih pumpi, naravno da će biti povećana potrošnja za električnom energijom, pa će i naš distributivni sistem, koji je inače vrlo neefikasan i troši 12% energije od ukupne potrošnje, to je gotovo jedna termoelektrana, morate da se svede na evropske standarde, to negde oko 4% opravdanih tehničkih gubitaka. Usklađivanje sa sve 4 direktive, ono što je vrlo bitno za sisteme za klimatizaciju i grejanje jeste da se novi sistem proračuna zgrada da uvede kako troše tu energiju, posebno za hlađenje, odnosno da se primjeni novi standard, a ne onaj 13.790 koji je ne samo nevažeć, koji je povučen kao standard i više nije u upotrebi, a mi dalje imamo procedure koje radimo po njemu. Modernizacija sistema energetskog sertifikovanja, nove oznake za nove zgrade, ali i za sve uređaje. Povlačenje fosilnih goriva, to sam već rekao, i sad su tu navedeni načini, ali formalno i suštinsko usvajanje i primjena ekodizajn i ekolabeling direktive, dakle da to zaista postane i obavezujuće za nas, da se vratno pripremi nekoliko pilot projekata u zgradama i toplanama koje će preći na nove način grejanja pomoću toplotnih pumpi i da probamo u nekim bar manjim gradima da pređemo da nam toplane budu na obnovljive izvore energije. Potom ne podrazumijem biomasu koja se, iako se i dalje imamo neke razvojne projekte prelaska na biomasu, nije pokazala kao ekološki prihvatljivo rešenje. Ono što bi bilo važno da kažem još da je i neophodna ova dodatna poboljšanje ovog informacionog sistema za energetski menadžment. Dakle, sistem postoji, to je jedan informacioni sistem, prikupljaju se podaci iz nekoliko hiljada objekata već u Srbiji. Naravno, treba ga malo prilagoditi, uvesti modul za sisteme daljinskog grejanja, malo definisati više kako će da se uvezu temperature, energija, snaga u taj sistem, dakle da ne bude samo ono što se potroši kao energija i voda. Treba izvršiti masovni prelazak na grejanje na toplotne pumpe, tu naravno opet treba da postoje neke subvencije, ne samo toplotne pumpe, nego i neke hibridne sisteme u nekim periodima. Treba da se razvije model subvencija da bi to bilo ostvarivo, pošto to je kao i sve ekonomski zahtevno, pa se ne očekuje da će biti moguće rešiti bez dodatnih subvencija. Spomenuo sam već modernizaciju sistema daljinskog grejanja, to je jedan ogroman posao, posebno za Beograd. Usklađivanje elektroenergetske mreže, korišćenje većeg broja toplotnih pumpi, morat ćemo da menjamo i distributivni sistem. Za ove direktive o energetskoj performansi zgrada, potpuno, dakle, da pređemo na to što se od nas traži i da uvedemo da nam je obaveznost zgrada B ili C, ali po novom metodu proračuna koji će uključiti sve potrošače energije. Godišnje uštede i monitoring trebalo bi da se ostvaruju kroz neki informacioni sistem, dakle da se očitavaju stvarne potrošnje, što već ovaj informacioni sistem energetski menadžment omogućava, i sve ono što se tiče obnovljivih izvora energije, rast udela O i E u grejanju i hlađenju. Sve u svemu, transformacija daljinskog grejanja, elektrifikacija grejanja i digitalna infrastruktura koja će pratiti sve te promene. Što se tiče inženjerskih izazova, dakle, ovo nije samo izazov za vladu, vlada će doneti regulativu, naravno, bit će joj neophodna pomoć inženjera da se sve to sprovede, jer niti ministarstva imaju kapacitet da tako nešto urade, niti je to evropska praksa. Dakle, uz vašu pomoć bit će neophodno da se sistem preuredi i da se konačno postave kvalitetna pravila usklađena sa Evropom, sa onim što trenutno Evropa radi, a ne da kaskamo 10 ili 20 godina iza nje. Kada se radi o promeni načina, prosto morat ćemo da promenimo način kako posmatramo objekte i o tome već bilo reči. Dakle, morat će se gledati zgrada kao energetski objekt kompletno sa svim termotehničkim sistemima, a ne izdvojeno motoč, prozori, a posebno termotehnički sistemi i morat će se primjenjivati integrisane mere, a ne parcijalne. Koji će biti glavni izazovi za sisteme grejanja i hlađenja? Pa trenutno su nedostatak podataka o performansama zgrada, o performansama sistema, veliki udeo zastarelih sistema, što možda i nije loše, jer ćemo ih menjajući prelaziti na nove i efikasnije. Mali je broj objekata, izuzetno mali broj objekata sa sistemima automatizacije i upravljanja i naravno neujednačena projektna praksa. Šta treba da se uradi u tom smislu? Pa, spomenuo sam ta ISM, njegovo proširenje i povećanje kvaliteta i da se urade neka tipizovana rešenja grejanja i hlađenja, klimatizacije, na primjer za škole ili za bolnice, koja će biti lakše primenjiva i moći će da se brže sve to isprojektu i pređe. Morat će da se uvede takozvani commissioning i recommissioning, dakle kontrola sistema i prilikom instalacije prve, ali i svake godine naknadno provera rada njihovog kvaliteta i usklađenost sa zahtjevima energetske efikasnosti i naravno spomenuti već minimalni tehnički zahtjevi, dopuna pravilnika o energetskim pregledima, projektovanju zgrada i tako dalje, prelazak na ne finalnu nego na primarnu energiju i uključivanje svih ovih sistema i obnovljivih izvora energije u proračune. Kada govorimo o kotlovima, više puta spomenuto, isključuju se kotlovi na fosilna goriva postepeno i razmišlja se o tome kako da se uvedu toplotne pumpe. Smernice treba da urade inženjeri, kako to da se uradi, a što se tiče same primene, pa opet bi trebalo da se rade neki pilot projekti blok po blok, da se vidi kako to funkcioniše, jer naravno prelazak odjedanput i gašenje sistema postojećeg je nemoguće, ali na vreme bar treba da počnemo da bavimo se sa time. Kotlovi individualno grejanje, subvencije da idu zasnovane na celoživotnim troškovima koje su koriste, da se ne gleda samo cena proizvoda, nego malo šire da se pogleda ceo i da se tehnički kriterijumi postave tako da imamo integralna rešenja, a ne pojedinačna. I naravno treba da se vidi to planiranje s elektroenergetskim sektorom kako da se pojačaju sistem distribucije električne energije. Kod sistema daljinskog grejanja treba će se da se trenutno relativno visoke razvodne temperature da se smanje, da bi se prešlo na nisko temperaturno grejanje. Naravno, to ima svoje ograničenja, pa će morati da se usklade i sami potrošači s tim, ali sa sprovođenjem mera energetske efikasnosti na termičkim omotačima bit će očigledno moguće da se spusti malo i temperatura grejanja. Naravno, nedovoljna digitalizacija, to nas prati u svim sektorima i neusklađenost unutrašnjih instalacija zgrada sa niskotemperaturnim režima koje će takođe morati da se usklade. Putevi implementacije, digitalni modeli toplana i mreža, fazni prelaz smanjenja temperatura, mape toplote, integracija otpadne toplote, standardizacija podstanica i unutrašnjih sistema. U gradovima kao što je Beograd i Novi Sad, još po nekim to je već urađeno i na visokom nivou, međutim imamo u Srbiji 60 toplana gde imamo mnogo lošiju situaciju nego što je to u ovim velikim gradovima. Spomenuo sam mapu toplote, integraciju otpadne toplote, dakle prvo treba da proverimo gde to ima. Jedan projekat se radi sada za Smederevo, tamo u Železari ima otpadne toplote, pa će se to primeniti, što je jedan od dobrih koraka, ali to treba raditi masovno. Imamo još uvek mnogo tih toplotnih izvora. Standardizacija, to sam već spomenuo. Zaključak, konačno zaključak. Dakle, treba da primenimo ove direktive zato što je transformacija ne samo elektroenergetskog sektora i sektora proizvodnje važna za Srbiju, nego i ovog sektora, uslovno rečeno, finalne potrošnje, ali i sistema daljinskog grejanja, jer jedino tako možemo da uhvatimo ne samo priključak Evropskoj uniji da ostvarimo te obaveze, nego da zaista učinimo naš jeftinijim korišćenje energije, da smanjimo potrošnju energije, da postanemo i manje zavisni od uvoznih energenata, bar ovih dana imamo prilike da vidimo koliki je to veliki problem za Srbiju. Transformisati sistem daljinskog grejanja, elektrifikovati grejanje, razviti informacioni sistem u sledećem koraku da može sve to da pokupi, da bi imali jasnu i preglednu bazu podataka i o potrošnji i o proizvodnji energije. Konačno, suština implementacije je ta da imamo efikasan sistem grejanja i hlađenja i da negde od 2050. godine i mi bar se približimo tom evropskom cilju da imamo nulte emisije i u sektoru potrošnje, a i u sektoru proizvodnje energije. Hvala na pažnji.
Zahvaljujemo se kolegu Banjcu. Ovim smo završili ovaj današnji plenarni deo predavanja, a sada vas obaveštavam da je koktel do 14 časova na donjoj koti, znači na prizemlju gde je izložbeni prostor do kraja. Tamo se nalazi jedan prostor gde je organizovan koktel dobrodošlice. Hvala vam na pažnji i hvala vam što ste došli.